Okay, so we've got information about what's going on in the muscles, about length, and now we have a sensory receptor system that's telling us information about the amount of tension or force being generated by our muscles. Okay, so you can see how that relates to proprioception, or where limbs are in space. Okay, those are pieces of information about what's happening in muscles, and that's going to help us determine where our limbs are in space. Okay, another nice receptor system would be, let's know about where our joints are, or where one body part is relative to another body part. Okay, and that happens because we have joints. So if my joint is at a certain joint angle, then that says that this body segment is a certain number of degrees away from this body segment. Okay, so it would be good to have joint receptors. Okay, so where are joint receptors located? Right? In the joints. So in the synovial joints, so we have proprioceptors, or these joint receptors throughout these joints. And they're in the joints, obviously. So again, what kind of information would we like from our joints? So at what length or what degrees the joint is in. Okay, and we'd like to know something about changes. And those, as we move through a range of motion, we'd like to know something. Okay. Oops. So initially it was thought that certain receptors fired at certain joint angles. So if I put my elbow at this joint angle, then I had a set of joint receptors that would fire. Okay, and that was presumably meant that, oh, my joint must be at this angle. And if I would move to this angle, then a different set of joint receptors would generate action potentials, and they would signal, oh, your joint is at this angle. Okay, it turns out that that's really not the case. Joint receptors provide their most information at the two extreme ends of the range of motion. And that means for elbow joint, at the extreme end of flexion and at the extreme end of extension. Okay, so the concept is joint receptors are most active when I'm either at this end of the range of motion or at this end of the range of motion. Turns out that joint receptors aren't really very active through the mid part of your range of motion. Okay, I mean, a few joint receptors are firing, so you're getting a little information about, okay, I'm here, whatever. But joint receptors become very active when you're either here at one extreme end range of motion or at the other extreme end of the range of motion. So what would be the functional value of that? Right, so it's the same reasoning. You've got a system that as you move toward extreme end range of motion, you are at what? Greater risk for injury. Okay, you could hyperextend or just go too far, too much tension again. So that's when you want the greatest amount of information. You're approaching, in a sense, a danger zone. You don't want to hyperextend, and in fact, that's what our sensory system does. As you get to those two extreme ends, you're getting a lot of information from your joint receptors. Okay, and again, the thinking is that's designed to prevent injury. Okay, you don't want to exceed your normal range of motions, or at least not by very far. Okay, you risk muscle damage, joint damage, etc., and joint receptors then become most active.